Assalamualaikum warahmatullahi wabarakatuh. Now we from the group 1, we will present to you the mini project of ECE523, which the title Smart Flooding Detection System by using Google Collapse, Xbot and Kaggle. So our group is include 4 members, which is me, is Nick Muhammad Mahathir bin Ya'mur, Muhammad Rafli, thirdly is Afiq Fikri, and lastly is Muhammad Rais. So, first of all, I will briefly to you about the introduction for our project, which is the smart flooding detection system. Why we do that? Because in our world, flooding is a very worse right now because the climate change and heavy rainfall in our world is not uncontrollable, and then many current warning system that apply is old and cannot give a real.
Okay, so I'll be presenting the problem statement. Okay, so first of all is the persistent flood threat in the global. So basically, flooding is a common and also destructive issues in global, which impact both urban cities and so rural communities. With each passing year, it already causes significant damage to homes, infrastructure, and also livelihoods. So despite being a known problem, effective early detection and also response system will remain limited, leaving many vulnerable population at risk. Okay, so next, we'll continue to worsen by climate change. So the effects of climate change have intensified this threat, which more frequent and heavier rainfall events have led to unpredictable and sudden floods, which as extreme weather patterns become more common, the urgency to adopt, I can say, smarter monitoring solutions grows even stronger. Okay, the next one is ineffective alert system. So basically, existing flood alert systems are often outdated or inefficient. So they provide slow response times, lack precision, and also unable to deliver real-time updates. So this delay in communication can actually be the difference between safety and also danger, particularly during sudden flash flood events. Okay, so the next one is need of localized monitoring. So basically, flood condition vary greatly, I can say, between regions, and one size fit all alert does not actually work. In many communities, I can say, still rely on generalized weather updates rather than the specific localized warnings. So basically, there is a clear need for a monitoring system that can deliver accurate alert based on real time and also location specific data. Okay, for the last one is IoT as a practical solution. So by integrating IoT sensors and real-time data analytics, so these projects actually offers a practical and also scalable solution. Okay, the smart flood alert system leverage environmental data and ThinkSpot can visualization to provide timely alerts. Okay, so empowering communities to actually respond earlier and more effectively. So this approach supports both local preparedness and also long-term climate adaptation efforts. So I think that's all for the problem statement. So let's start. So the first objective is real-time monitoring. So basically, the project aims to continuously monitor environmental condition using IoT sensors. Okay, so basically, these devices will select real-time data on key variables such as water level, rainfall intensity, temperature, and also humidity. And this ensures constant and accurate flood risk assessment. Okay, so the next one is automated alert system. Well, another core objective is to develop an automated alert system using the ThinkSpot platform. When any monitored variable exceeds a predefined safety threshold, such as rising water level, the system will eventually instantly trigger an alert that giving affected individuals time to take necessary precautions. Okay, so the third one is location-based visualization. So the system incorporates GPS coordinates into the data system, which allow for precise visualization of sensor location. Well, this helps identify high-risk areas on a digital map and ensures that alerts are sent only to relevant regions, which will avoiding unnecessary panic in unaffected zones. Okay, the next one is improve community preparedness. Okay, so by providing early and also accurate warnings, the system enable residents and emergency services to basically act promptly. Well, this can reduce the number of casualties, minimize infrastructure damage, and also enhance the overall readiness of communities during flood events. Okay. The last one is support sustainable development goals, which is support the SDG. While this initiative is designed to support global sustainability efforts which align specifically with SDG 11, SDG 13, and SDG 3. And I can say through the integration of smart technology, the project will contribute to safer, healthier, and more climate resilient communities. I think that's all. Thank you.
Okay, next, today I will present our smart flood detection system that send the real-time data to the things board by using a Google Collapse and also IoT sensor. So first step is mount Google Drive, which is we mount the data that we get from the Kaggle to access into the Google Collapse by CSV file. And then step 2, we install the required libraries, which is import pandas SPD, import request, import JSON, and import time. And then step 3, we load the flood risk data from the Google Drive, which is from the CSV file that we get from the Kaggle. And then the step 4, we map and reprocessing data by we rename column for easier reference that we get from the data set into our required variable, which is temperature, into the max temperature. And then for the step 5, we function to prepare telemetry data by different telemetry data to function to convert all variable into the telemetry format. Assalamualaikum warahmatullahi wabarakatuh. Okay, I would like to share with you about the result of our things board. The smart flood detection system demonstrate effective threshold-based monitoring where alarms are triggered when parameters exceed predefined critical values. This is a programming established this threshold based on hydrological safety limits. There is water level is above 7 mm, indicates flood danger. Rainfall is above 200 mm, suggests extreme precipitation. Temperature is above 33 degrees Celsius, signal heat risk, and humidity is above 80%, signifies saturation potential. During operation, the system successfully activates critical alarm when the water level peak at a meter, exceeding the 7-meter threshold by 40.3%, demonstrating its capacity to identify actual flood conditions as defined by FEMA 2022. First stage, the classification. While rainfall reached 181 mm, 90.5% of the 200 mm threshold, and humidity hit 79%, there is 98.9% of threshold. This value didn't breach the critical limits, showcasing the system position in avoiding false alarm. There is a key requirement for reliable early warning system according to WMO 2023. The temperature dropped from 43 degrees C to 35 degrees C. The temperature will be increased or decreased below the 33 degrees C threshold. Further validate the system ability to track environmental transition from dry to flood risk condition, consistent with monsoonal pattern documented by IMD 2023. This threshold-based logic ensure alarms are only triggered when parameter costs scientifically established danger levels, balancing sensitivity with specificity as recommended in flood monitoring literature. The 24-hour period saw one confirmed critical alarm, that is water level, and three near threshold events, proving the system capacity to both detect actual emergencies and provide warning of developing risks.
Okay, now I explain for the calculation part. This project effectively created a smart loss detection system powered by IoT and data analytics, which is essential for early flood warning and real-time monitoring. The system has achieved its goal by precisely tracking important climatic factors such as temperature, humidity, rainfall, and water level, and displaying a flood risk on a centralized product dashboard based on the threshold. It successfully sent out early warning notification in less than 91.5 hours. It produces four main alerts such as high water, high humidity, heavy rain, and low temperature. It meets international flash flood warning criteria and tests to its precise real-time reading under a variety of situations during trial. That's all from us, and thank you very much.